Hello students, welcome to JCE Connect. Subject groundwater and hydraulics, 17 CV 742. In today's class, we will discuss about the permeability of the soil. So, permeability is defined as the property of soil which permits the flow of water through it. So we have discussed what is porosity in detail in the previous class, right? So porosity is the voids present in between the soil particles, that is called as porosity. The gaps or the openings which are present in between the particles, they are called as voids. So when these voids are present in the soil and when they are interconnected, what happens? The water can flow through the soil very easily. So that is what called as permeability. So the ease with which the water can flow through the soil. So here in the image you can see this material is non-porous because there are no pore spaces available, so it is not permeable. It is non-permeable because there are no pores, there is no storage of water and there is no circulation of water. But here you can see there is uncompacted material, okay, that is loose, so there are pores present in it. So but these pores are not interconnected, unconnected pore spaces are present. So this is a porous material, but it is again non-permeable. There is no permeability seen. Permeability is water will not flow from one pore to other pore. That is called as non-permeable. It is porous, but it is non-permeable. But in here in the third you can see all the pores which are present, they are interconnected. So these pores are interconnected, and so we call this as the porous and permeable material. So the ease with which the water can flow through these pores, that is called as the permeability. So the soil, a soil is highly pervious when the water can flow through it easily without any obstructions. If the water is flowing easily, then we call it as permeable material. So in an impervious soil, the permeability is very low, as discussed here, right? The permeability in impervious material is very low and the water cannot easily flow through it. So example for impermeable soil is clay. Why clay? Because the clay particles are very fine, okay, and the pore spaces are very less, and as a result those pores are not interconnected, and that is why we call the clay as impervious soil. Then the rocks which has openings, like the rocks which are jointed, which have cracks, those rocks are permeable, but usually the hard and compact rocks, they act as a impermeable material. So rocks are usually impermeable, hard rocks. So here one more image to make you understand more clearly what is mean by permeability. So here the distance or the thickness of material is 1 meter, okay. So in the first image there are gravels, in the second image there is a layer of sand, there is a silt and the clay. So these all are in the decreasing size, grain size, okay. Gravels are bigger in size, sand are finer than sand are silt, and clay is the finest material. So here what happens, if you pour water in all these mediums at a time, then what happens? You can see clearly here, it will take only 2 minutes, okay, to go down and come out through this opening at the bottom, okay. This is in case of gravels. Then in the next image you can see it is taking 20 minutes for sand to percolate the water Okay, so it is percolating and you can see the water coming out is comparatively less than gravel. Then next, if you talk about silt takes 2 hours time. Okay, the thickness of the material for all is only 1 meter, but because of the grain size difference it is taking more time. So here 2 hours are needed for the silt for the percolation of water. Then lastly, clay again it is still finer, so it takes 2 days time for percolation. So this is how the grain size affects the permeability of the material. So I hope you have understood what is mean by permeability. So these pores are interconnected, then this can pass through easily, the water can pass through easily through these pores. Okay, so that is called as permeability of the material. Then permeability is a very important engineering property of soil. So the knowledge of permeability is essential for this is essential for the settlement of building, then yield of wells, seepage through and below the earth structures, earth pressure and uplift pressure under hydraulic structures. So when you deal with all these parameters, you will come across the concept of permeability. So this permeability, knowledge about the permeability is essential for when you construct the buildings undergo settlement because of the properties of the soil which change with the water availability. Okay, then yield of the well you need to find out in case of water supply schemes. Okay, then seepage through and below the earth structure. So what amount of water is seeping through, this is usually helpful in when you construct the dams and tunnels. Okay, then to find out the earth's pressure, then uplift pressure under hydraulic structures. So when you deal with different hydraulic structures, there also you need to calculate the permeability. Then we'll discuss what are the factors which affect the permeability of the soil. So first important factor is particle size, as I have shown you in the image right here. The particle size affects the permeability. If it is greater, okay, if the particle size is greater, that is in case of gravel you can see the particles are very big in size, and as a result the porosity and the permeability will be more. But here for the clay it is a finer material, so it is less, the permeability is less. So this is how the particle size is the first factor on which the permeability is which affect the permeability of the soil. Then comes the properties of the pore fluid. Okay, the fluid which is passing through these medium. Okay, usually for groundwater studies we talk about the water. So what are the properties of that water which is flowing through these underground, okay, material? Then the void ratio of the soil means the porosity, right? How much voids are present in between the soil particles. Then shape of the particles, then what is the structure of the soil mass. We have discussed when we were discussing about the porosity, whether it is cubic packing, then rhombic packing. Okay, this we had discussed. Okay, so this is how the structure of the soil mass, then shape of the particle, if it is coarse grained, okay, if it is well rounded, porosity will be more. If it is irregular angular fragments, the porosity will be less. Okay, and as a result permeability also will be less. Then degree of saturation, how much amount of water is present or it is absorbed water. Then impurities which are present in the water. So all these are the factors which affect the permeability of the soil. Then we'll understand what is mean by laminar flow and turbulent flow. This is very important before we deal with the Darcy's law. We need to understand what is mean by laminar flow. So laminar flow means the water particles of the water follow defined path, they never intersect, means like this the water is moving, okay, and it is the particles which are present in the water, okay, they follow a defined path, they will not cross each other, it will travel in a defined path, they never intersect their path, that is called as laminar flow. Whereas the turbulent flow means it is irregular, like this you can see they are the particles, they intersect each other, so that flow is called as the turbulent flow, or you can call it as irregular flow. Then let us understand what is mean by hydraulic gradient. So here there is one water body, okay, there is a aquifer, okay, and this is the water table. Then there are two wells which are dig in this aquifer and which are separated by 1000-meter distance, and the water level in the well, suppose this is A and B, okay, in the A well the water level is up to this height, okay, and in the well B the water table is up to this height. So what is mean by hydraulic gradient? So hydraulic gradient is the line joining the points of highest elevation of the water in a series of vertical open pipes, okay, which are rising from a pipeline in which the water is flowing. So here the difference in the two wells, the water level difference, here it is up to this height. So if you take the difference between these two levels of the water, it is around 2 meters, okay. So what is mean by hydraulic gradient? The difference in the water table, okay, divided by the distance, so that is 2 divided by 1000, that is 0.002 is the hydraulic gradient. So these are the basic concepts which you need to understand before starting the important concept of this module, that is Darcy's law, okay. So we'll discuss now what is mean by Darcy's law. So in 1856 Henry Darcy, he was a French hydraulic engineer. So on the basis of his experimental findings he proposed one law, and that law we call it as the Darcy's law. And the statement of Darcy's law is the velocity of flow, that is V, through a porous media is proportional to the hydraulic gradient. So what is given here, the statement. To understand this, let us discuss this figure first. What is given in the figure? So here in the figure there is a inclined cylindrical tube which is filled with porous media. So this is the inclined tube which is filled with sand column. Sand is a porous material, so it is inclined cylindrical tube which is filled with sand that act as a porous media. So the water is put in the system through the inlet on the left. Here you can see there is a inlet for this, and we are sending the water into the tube, okay, or the cylinder. So the water is put in the system through the water inlet on the left, and it comes out from the water outlet on the right side. Here you can see it is coming out and it is following this path, okay. There is a gradient, Okay, so the water in the cylindrical tube that flows from left to right, as shown by the arrow here. The water is flowing from inlet, it is coming into the pipe and it is flowing downward, and it will come out from this outlet. So the water in the main cylindrical tube, it flows from left to right. Okay, and there are two vertical small diameter cylinders, okay, which you can call it as piezometers. You can see here there are two piezometers which are inserted into the sand column, okay, near the water inlet and outlet. So for what purpose we are inserting these piezometers? For the purpose of measuring the head of the water which is flowing through the porous media. So at the entry and exit position in the given experimental setup. So this is a given experimental setup wherein we have inserted two piezometers, okay, for measuring the head of the water flowing through the porous media, that is sand. Okay, so what the Darcy statement is, the velocity of flow. So what is the velocity of the flow of the water which is flowing through this media, that is sand, the porous media, that is proportional to the hydraulic gradient. So this is the hydraulic gradient, change in the water level, right? So here we'll see the equation for this, Darcy's law. So the velocity, that is V, is proportional to the hydraulic gradient, that is I. I stands for the hydraulic gradient. So this we can write it as, so V is proportional to dH by dL. So what is dH by dL? That is I, that is nothing but the hydraulic gradient. So here you can see the difference in the height, that is H1 and H2, okay, that is dH, and they are separated by a distance. Okay, here the distance between the two piezometers is L. Okay, so dH by dL, that is the difference in the head, that is hydraulic gradient, we can express it as dH by dL. Then we can also write this as V is equal to minus K dH by dL, where the K is what? K is the constant of proportionality, which is known as the hydraulic conductivity. The unit of hydraulic conductivity is meter per day in the direction of the flow. So here we have added a constant of proportionality, and that is called as the hydraulic conductivity. So and V is the Darcy's velocity, okay, and K is the constant. So the rate of flow across the cross sectional area, if you take, that is A is the cross sectional area of this pipe. Here it is shown in the figure, area, that is A. So this expression we can rewrite as Q is equal to, so Q is what here? The rate of flow across the area A, that can be expressed as Q is equals to VA. So here Q is the discharge, you can say, or the rate of flow means the discharge. So Q is the rate of flow across the area A. So this expression we can write it as Q is equals to VA. Then we know the value of V here, that is you can call it as expression 1. From equation 1 we can replace the value of V, we can substitute as minus K dH by dL, and A remains as it is. Yes, so this is equation 1. Okay, so from 1 we can write this equation, Q is equal to minus K okay, V is replaced by minus K dH by dl, and A remains as it is. So this is the Darcy's equation, wherein Q is the rate of flow of water, or you can call it as a discharge, okay, and K is the hydraulic conductivity, that is a constant, and A is the column cross sectional area, and dH by dl is the that indicates the hydraulic gradient. Then what is mean by minus? Why there is a minus sign? So this minus sign indicates what? The flow which is happening through this pipe or the cylinder, that flow takes place in a direction of falling head. So that is why we have taken the sign as negative. So this is the Darcy's equation or Darcy's law. So this expression we can write for the different coordinates, like in Cartesian coordinate system, for the velocities in the three different directions, that is x, y and z direction, we can rewrite as Vx is equals to kx when it is in x direction, dh by dx, okay, and Vy, that is in y direction, ky dh by dx, and Vz, that is in z direction, we can write this as the same equation, okay. So this is about the Darcy's law, which is a very very important concept, often asked in all the question papers. So derive an expression for Darcy's law. This is very important question. Then in the next class we will discuss the validity and assumptions which are made in the Darcy's law. Thank you.